We're going to be solving and writing fraction division word problems using the measurement or how many groups perspective of division. Our first word problem is a tricky one because we're going to have to interpret the remainder. The soup kitchen serves each visitor 1 2/3 cups of soup. A pot of soup holds 9 cups of soup. How many visitors can they serve from one pot of soup? How many cups of soup will be left over? In this case, we can see that 9 cups will be our total amount of soup, and we'll be measuring out batches of 1 2/3 cups of soup. Each of these servings will go to a single visitor. The visitors will be our groups. So we're asking how many groups or how many visitors can be served. Our division problem is 9 cups of soup divided by 1 2/3 cups per visitor. And that's going to tell us how many visitors, the visitors are our groups, we can serve. Because we're solving with a double number line, we want to have consistent units. We want to have a common denominator. So let's set this problem up as a common denominator problem. It becomes, with 3 as our common denominator, 27/3 divided by 5/3. So to set up a double number line, we'll have 2 number lines stacked on top of each other. The top one is going to be our cups for our total, and the bottom one we're going to keep track of the number of visitors. Since we have a common denominator of 3, each tick mark on the top will represent 1/3, and then we'll have a corresponding tick mark on the bottom that for now we'll leave unlabeled because we'll have to relate it to visitors. So I'm going to take a moment to set up my number line. Okay, so now I have my number line set up, and I'm going to circle groups or measure out groups of 5/3 cups of soup. Here's my first one, and that corresponds to 1 visitor that's been served soup. I keep circling my 5/3 cups, and I keep track of how many visitors got soup. Notice that I'm going to go past my total. My total was 27/3, which I'll mark on both the top and the bottom number line. So that means 5 visitors got soup, and we had some left over. So as I solve this problem, I could divide my numerators, divide my denominators to get 27 divided by 5, or 27/5 as a mixed number, 5 2/5. So the 5 works, but what to do with the 2/5? The 2/5 represents here 2/5 of a visitor, or really 2/5 of a serving, but the question didn't ask how many servings would be left over. The question asked how many cups of soup. So the 5 2/5 represents the visitors, which we could also think of as the number of servings that we have. But now we've got to figure out what to do with 2/5. We want to know how many cups are left over. So we can see that our leftover amount actually is 2 spaces, which corresponds to 2/3, since each space is 1/3, 2/3 cups left over. So our answer is 5 visitors get soup, and then we have 2/3 cups left over. This is such a hard problem because people tend to want the 2/5 to be the number of cups left over. But remember, the entire quotient, the entire answer represents visitors. How many visitors? So 5 2/5 visitors, or 5 2/5 servings, not cups. So what if we hadn't had a double number line to help us? Could we have gotten to 2/3 of a cup? Yes, indeed we could have. Let's look and see how. So I knew that I had 5 visitors, and then I have this 2/5 floating out there. What is the 2/5? This is 2/5 of a serving, or 2/5 of a visitor, but we can't cut a person up, so 2/5 of a serving. What was a serving? 2/5 of is multiplication. A serving was 5/3 cups. We want 2/5 of 5/3 cups. We can multiply that out and see that this is going to be 2/3 of a cup left over. Let's go to another problem. If one recipe calls for 3/4 of a cup of sugar, but Marcy only has 2/3 of a cup of sugar, what fraction of the recipe can Marcy make? We're going to use a different strategy this time. We're going to use a table strategy, but let's think about what our problem is. So in this case, how much sugar does Marcy have? She has 2/3 of a cup of sugar. This is going to be our total. Then we know that one recipe uses 3/4 of a cup of sugar, so this is going to be our group size, where one recipe is 3/4 a cup of sugar. So let's go ahead and set up a table. We have our cups of sugar and we have our recipes. We know that one recipe calls for 3/4 of a cup of sugar, and we're trying to figure out if we have 2/3 of a cup of sugar, how many recipes can we make? So we're looking for how many groups of 3/4 are in 2/3. Let's stop and think for a minute. Is our answer going to be more than one recipe or less than one recipe? Marcy doesn't even have 3/4 of a cup, so reality check, whatever answer we get should be less than 1 because she can't make a full recipe. So the way we would use a table is we would start and say, well, we're measuring out, and when we're doing measurement problems, it can make sense to have a common denominator. So here we'll have a common denominator of 12. We'll have 9/12 here, and we'll have 8/12 here. And then we want to figure out how we can get from 9/12 to 8/12. Our first step is going to be to divide by 9, divide by the numerator. That gives us 1/12. Then we want to scale it up to our desired number of cups, so we're going to multiply by 8. 1/12 times 8 gives me 8/12. So over here, to keep the same proportion, we're going to divide by 9. So this means 1/9 of a recipe uses 1/12 of a cup. And then we're going to scale up by 8. And so our answer is going to be 8/9. If she has 2/3 of a cup of sugar, she can make 8/9 of a recipe. So what did we have here? We knew the group size, we knew the total. We are going to have the division problem. The total was going to be 2/3 of a cup divided by the cups in one recipe. This is our group size. And then we're going to be figuring out how many groups or how many recipes can we make. 2/3 divided by 3/4 is the same as 8/12 divided by 9/12. If we divide the numerators and divide the denominators, we end up with 8/9. So what do we have? We have 8/9 of a recipe. Looking back at what we did here, what our strategy was, we found a common denominator. We went to the unit fraction, so we divided by the numerator, and then we scaled up to whatever the new numerator was. We did the corresponding operations with recipes as well. Finally, let's write a word problem. 1 7/8 divided by 3/4. So we can start this by labeling our generic measurement problem. We have some total number of units. We're going to divide it by the group size, or the units in one group. And then our answer is going to answer the question, how many groups? So we think to ourselves, what can we measure out in batches of 3/4? I'm going to make this paint, and I think of paint as coming in gallons. So let's say 3/4 of a gallon can paint one room. So what's one group? One group is one room, and that uses 3/4 of a gallon. So over here, if my units were gallons, then I'm going to have total gallons as my dividend. And I'm going to be looking for how many groups. What were my groups? My groups were rooms. So I want to know how many rooms. All I need to do now is make this into a story where I have some number of gallons. I know that 3/4 of a gallon paints one room, and then I ask how many rooms. The Yang family has 1 7/8 gallons of paint. Each room they paint requires 3/4 of a gallon of paint. How many rooms can they paint? So this becomes 1 7/8 divided by 3/4 will answer the problem. Let's just solve it really quickly. I'm going to get I'm going to write this as an improper fraction. So I'll have 15/8 divided by 3/4. I notice that I don't need a common denominator because our numerators and denominators are multiples of each other. So I'm going to make this 15 divided by 3, 8 divided by 4, 5/2, or 2.5. What does my answer represent? My answer represents how many rooms, so they can paint 2.5 rooms. I might wonder how much paint they have left over. Well, I know they have half a room's worth of paint left over, so they have half of a room. How much paint is required for a room? Half of 3/4 of a gallon. So I have half of 3/4 or 3/8 gallons left over if they didn't choose to have a room that was not completely painted.